Have you ever completed a project to only find out later that some of it is barely used or not used at all? This situation is quite common, and it leads to frustrations for developers and stakeholders alike. Creating software can be challenging, but so is establishing what software needs to be created. The key to minimizing the risk of writing code that nobody asked for is clear communication. This is what behavior-driven development aims to solve. I'm Jakub Sobolewski, and I'm staff engineer at Epsilon. During my 4 years at Epsilon, I've focused heavily on automated testing. I've learned that when we do testing right, tests are an accelerator for our development efforts, not an obstacle or an afterthought. In this talk, we'll see how automated testing can help us get better at one of the most difficult aspects of software development, transforming requirements into working code. Behavior-driven development has many names. You might find that someone calls it acceptance test-driven development, specification by example, or executable specifications. If you decide to look it up later, use one of those names. So let's first define what is behavior-driven development. Then let's see how we can practice it. And in the end, we'll take a look at Cucumber, a tool that facilitates behavior-driven development. We do automated testing for a purpose. It shouldn't be just something our managers tell us to do. Before writing tests, we need to know what we write them for. Only then we'll write tests that are actually useful. We can define two types of tests that serve different purposes. Unit tests tell us if each part of the software is working correctly. For example, whether calculations are done right. They test all the pieces in isolation. Acceptance tests tell us if we build the correct software. They tell us if users of the software can achieve their goals. They test if all the pieces are working together as expected. And this is what we focus on today, acceptance tests. This pyramid symbolizes the split of amount of each type of tests one should have. We should aim for having fewer acceptance tests than unit tests. Behavior-driven development is a collaborative process. It brings together business experts, developers, and testers. Business experts are the ones who know what users need. Or if we're not working with business experts, we might work with users directly. Developers are the ones who build the system, and testers ensure quality. Developers and testers might be the same people. This might be the same team. But the main and most tricky part of this setup is the communication between technical and non-technical folks. The process usually looks like this. It starts with a vague wish from the user. It has little to no details. Then we translate it into a user story. We capture this wish in a more structured way. We define what it is and whom will it benefit. Then we write down executable specification. It is a more precise version of a user story. And in the end, we write tests and code. Yes, you heard that right. Tests and code. We write tests first because how can we write code if we don't know what it needs to do? Knowing how to write tests for something that doesn't exist yet is a final check if we understand what we need to build. We work with the business experts or users on the first 3 steps of this process. When we have specifications written down, developers and testers take over and implement the system. Each step in this process adds more precision to the requirements for software we're about to build. It minimizes the risk of building something else than was requested. With BDD, we write executable specifications for each user need, and we know exactly when we are done writing our code. It is when all specifications pass. So how those specifications look like? We write them in a language both business and developers understand. So let's imagine we're building a flight booking service, and one of the requirements is to allow users to book a flight. BDD suggests using keywords that structure our specifications. We use given keyword to specify all preconditions for our software. Here we describe, for example, that some data should be available when the software runs. We use when keyword to describe actions users take with our software. We use then keyword to describe outcomes that can be observed by users. So, for example, for our booking service, this could be given an available flight on my preferred date, when I search for flights from London to Paris on my preferred date, then I am offered the flight. It is crucial we don't reveal implementation details in specifications. When writing them, imagine at least 3 different ways to achieve the same goal. Imagine we could run our software in our console, or it could be a Shiny app, or even a mind control interface. If our specifications don't work for all of them, it's most probably because we reveal implementation details. So this is our hint to rethink the problem. Include only information that is essential to describe the behavior. So if we describe the action as when I click search button and type London and Paris and select my preferred date, we reveal a ton of information about our system. So we see that it has a graphical interface. This is bad specification. We need to be abstract. Each sentence in specifications must be abstract but precise. It's what makes specifications stable and robust. If we look implementation details, then we will need to update the specification every time our software changes. And you probably won't get those sentences right on the first try. It takes some time to get it right, but you refactor them as you learn more and more about the business domain. Stay abstract. Don't dive too deep into implementation details. Don't design everything up front. Leave space for innovation. Implementation details are needed, but not at this level. Here we focus only on the behavior of the users. So once we have our specifications written down, now it's time to execute them. And we can do this with Cucumber package. There are 3 elements to Cucumber tests: feature files, which contain our specifications; step implementation. It is the code that connects specifications with our system; and hooks. This is the optional code for setup and teardown. We put our specifications in files with feature extension. The first keyword is the name of the feature we're building. A feature can contain multiple scenarios. So think of a feature as a test suite, while each scenario is a test case. We build scenarios from common steps. We should reuse steps to create all the scenarios we need. And the number of steps we need to define to test our system should be far smaller than the number of scenarios we create. This is what is needed to make those steps reusable. What makes this approach especially useful is that we can be verbose in describing the feature. We can, for example, provide extra non-functional descriptions to provide additional context for people reading them. After we put specifications in feature files, we can write step definitions. We create them by calling given, when, and then Cucumber functions, and we pass 2 arguments to each. First parameter is the description that will be matched against sentences in feature files. The second ones are functions that will be executed. We can use special Cucumber syntax to parameterize those functions, which allows us to reuse steps in multiple scenarios. So if our first step in a scenario was that we have an available flight, Cucumber would first run the given function that sets up the environment with test data. Next, Cucumber would call the when function, which imitates user interaction with the software. And at the end of the scenario, then function will be called, which verifies the outcome. So here you can see that we have two then functions. One is to verify a single flight. It will only match exactly on the sentence, I am offered the flight. The other one is used to verify multiple flights. The end word in braces allows this step to be matched against any sentence that has this format and includes integer number of flights. Think of it as a special case of regex. The third part are hooks. They let us do extra setup and cleanup before and after scenarios. For example, we might want to create a database or start a test server before we run each scenario. You can organize Cucumber tests alongside your tests, unit test in test.dat directory, or in a separate directory. This flexibility helps you integrate BDD tests smoothly into your workflow. If your acceptance tests are fast, put them alongside unit tests. If they take longer to complete, as it's usually the case with Shiny app tests, you're probably better off with placing them in a separate directory, so you can easily launch one or the other. Remember, behavior-driven development is not about tools. It's about cooperation and shared understanding. You can do it without Cucumber or any other tool. Tools can help you. They can reduce overhead. But just using those tools doesn't mean you do behavior-driven development. We could do BDD specifications with only test.dat. If we structure our code correctly, such specifications could be almost as clear as Cucumber specifications, and we have full control of how we express them. If we decide to use Cucumber, we use an opinionated approach, so choose what feels right to you. Without Cucumber, test cases are written in code. It might be actually easier to start with, but scaling this approach might be tricky, and it might be more difficult for non-technical folks to understand such specifications. With Cucumber, tests are written in plain language, so they can be understood by anyone. It is also great for separation of concerns, and in the end, we might end up with a more robust test suite. Still not convinced? Check out Cucumber and MuteTest on GitHub to see how Cucumber is used in real life for testing R packages. I hope you enjoyed this talk. Feel free to reach out to me on LinkedIn or check out my blog where you can find testing and software development advice. Thank you.